So today we are going to start a new series in which I will be teaching you all the concepts of power system. In this first lecture, we are going to learn about the introduction of power system and some concepts. So let's start. So basically, what is power system? So power system refers to a system in which we generate, transmit, and distribute the power. So basically, power system is the system in which we generate, transmit, and distribute the power. So first is the generation, then second is the transmission, and then third one is a distribution. Okay. So generation, we generate in India, we generate approximately 11 kV to 25 kV. Yeah, so basically 11 kV is generated in a power plant and then it is stepped up and then transmitted through a transmission line which has a capacity of around 220 220 kV to 400 kV. And then next is distribution, in which the power which is transmitted we again step it down and then we trans then we distribute it for 440 to 220 volts. Okay, so this is typically what power system consists of. Then in power system also there are different ways to generate power, whether it be a thermal power plant or a hydropower plant, wind power plant. So there are different ways in which power can be generated. So moving further, we will learn what about SLD, like a typical SLD of a power system. So this this is this is a generator in which this is a generating station where power is generated and then power is stepped up. So this is a transformer, step up transformer. So this is also a step up transformer, and this is a transmission line. Typical transmission line has a transmission capacity of up to 220 kilovolt to 400 kilovolt, and then again that transmitted line is then again stepped down to 33 kilovolt and 133 up to 133 kV. Okay, so then it is then move further connected to a medium large consumers which requires 11 kilovolt of power supply, and further moving further it is then again stepped down for small consumers up to 220 to 430 kV. 430 kV. Okay, so this is typically a SLD of a power system. Now you must have a doubt that why 400 kV not generated directly. Okay, right? So the reason is due to problem of cooling, insulation, and material. Okay, so due to voltage pooling, and then insulation material, we will require like a good insulation material for generation of a 400 kV, right? So and then material will also differ. So these are the probable reason why we not generate directly 400 kV, and instead we generate 11 kV, and then we step up to 400 kV, right? So when the voltage increases, current decreases, right? Okay, so power transmission is directly proportional to the square of voltage. Okay, so keep this in mind that square of voltage is directly proportional to the transmission. Okay, then what is electric grid? Electric grid is a system used to deliver electricity from producer to consumer. Okay, so typically a grid is a line in which power is supplied, and from that we can take the power to our system. Okay, so this is called as typically a grid. So in India there is a power grid India which provide a grid system all over India. Moving further, there is a voltage classification. So voltage classified in low voltage, medium voltage, high voltage, extra high voltage, and ultra high voltage. Okay, so the low voltage ranges up to 0 to 1 kilovolt, medium voltage from 1 kV to 33 kV, high voltage from 33 kV to 220 kV. Then after high voltage there is also EHV, that is extra high voltage, and UHV, that is ultra high voltage. So the extra high voltage ranges from 220 kilovolt to 760 kilovolt, and then ultra high voltage is above 765 kilovolt. So typically extra high voltage and ultra high voltage are transmitted in HVDC system, because that is much preferable, because there is the risk of transmission losses are reduced in HVDC system. So in 220 kilovolt to 760 kilovolt, we typically have a DC transmission, that is a HVDC transmission. So moving further, now we are going to learn about various system of power transmission. Okay, so basically we use three phase AC system for transmission, but there are different systems which are DC system, AC single phase AC system, three phase AC system with three wires, and then three phase AC system, four wires. Okay, so these are basically various systems of power transmission. In that also DC system we have DC two wire system, then we have DC two wire system with midpoint ordered, then DC three wire system. In single phase AC system we have single phase two wire, then single phase two wire with midpoint ordered, and then single phase three wire system, right? Moving further, we have two phase AC system also, right? In that two phase AC system we have two phase four wire, two phase three wire system. In three phase AC system we have three phase three wire system and three phase four wire system. So typically these are sub classifications of all the various systems of power transmission, which is DC system, single phase AC system, two phase AC system, and three phase AC system, four wires. Okay, now there will be a question in your mind that how we can compare, or we can choose the right wire for the transmission. Okay, so for this possible system of power transmission, it is difficult to say that which is the best system until and unless some comparison is made or adopted, right? So the best system for transmission of power is that with the volume of conductor is minimum. Okay, so the if the volume of the conductor is minimum, then we can say the transmission system selected is a good one. So directly we can say that the volume of conductor material required forms the basic comparison between different system. Okay, so we have to compare the volume of conductor material required between different system, so we can select the appropriate system for the transmission.